Thanks. So I'm an entrepreneur and engineer. I've started a bunch of companies, but most notably probably Instructables. And I now work at Autodesk, where I continue to run the Instructables business. I also build labs. So I built our Pier 9 creative workshop in San Francisco. And then the thing I want to talk about today is the other thing I do, which is building our Autodesk's hardware business. So my group designs and manufactures our Ember 3D printer. I was here 4 years ago, where I spoke about how 13-year-olds in rubber bands powered an open source Connects gun community on Instructables. Just for update, that Connects gun community is still going extremely strong. And then finally, and probably most importantly, the little girl who was distraught about not getting to pull the trigger on shooting her first duck that Anne-Marie showed is actually my daughter. This is Ember. Ember is a stereolithography DLP printer. And what that means is we have a projector, and the projector projects an image into a UV sensitive glue, and layer by layer builds up a part. Let's see a video of that. This is a time lapse, so this print takes a couple of hours, but what's happening is each layer is being photosensitively cured by that projector and then lifted out of the vat of goo. This is Ember in a jeweler's studio. So Ember's really designed for jewelers, dental labs, and researchers, and this is how it actually looks for real in a jeweler's studio. And jewelers really like Ember because of the high resolution. These are some peacock feather pendants that a jeweler's making. And this is a microscope image of them. The scale bar, which you probably just can barely see, is a 1 millimeter. So the resolution on the machine is 50 microns X and Y, and then down to 10 microns in Z. So the voxel size is 50 by 10 microns. And the materials that we've worked on are intended for post-printing processes. So what that means is you print something in this photoactive polymer, but then you take it through investment casting. So you cover it in a ceramic slurry, burn out the polymer, and then backfill with metal. So in this picture, the blue is the investment casting resin we developed, and then the silver is actually the silver peacock feather. This is some other jewelry that we've done. This is a dental guard. So dentists will use this to help operations of the teeth. So they'll print a guard like this to then help guide them in some of their operations. And these are some bridges. So one of our dental lab customers integrated Ember, and in less than 2 months printed 1,000 of these bridges and crowns. So they integrated it into their business and started selling stuff very quickly, which is awesome. I love it when our customers can make stuff. And one of the reasons they really like Ember is because it's built for a production environment. So this is the software that drives the thing, and it's intended for multiple machines and multiple users. So multiple operators can come in and set up prints and get things going, and they can look at their whole effectively factory of printers making, in this case, bridges. So you might think, doesn't Autodesk make software? What is this with a 3D printer? And yeah, that's true. And that actually presented a little bit of a problem. So I actually started this hardware group secretly. And this is a picture of a storage closet. So this is where we were for the first 6 months. And inside the storage closet, I packed in a bunch of hardware engineers, and we secretly built this product under the nose of tax, legal, finance, and anyone who could really get in our way before we announced. And we took this from idea of we're going to do hardware into actually shipping to customers in 11 months. So it was an extremely rapid process. But there is a connection to the broader software, which is we're working on software to make 3D printing better. So we're working on this platform called Spark, which is software for 3D printing. And the idea is that the software for 3D printing is sucked for something like 2 decades. So we're trying to make it a bit better. And Ember is the reference hardware for how we think people should use our software. So the idea here is we can show the connected workflow from design all the way to printed part using all of the Spark platform with Ember. Now, because we're new to this hardware game, we can think a bit differently about it. So this is actually the formulation for our resin. Most 3D printer companies effectively sell razor blades. They sell you the resins or the materials, and they do so at extreme markups. But because that's not what we're after, we can open source our resin. So this is literally the formulation of the resin that we sell. We encourage people to make it, remix it, change it up, and make it themselves if they want to. We've also open sourced the hardware. So this is the hardware for Ember, and this is fully available on Fusion. So you can go and you can check out what's going on. You can then presumably you can potentially make it yourself. I will say that a bunch of the parts are injection molded, so it's not exactly practical, but this is more of it's about opening and showing what we're doing and how we did it. So having an open platform actually leads to some interesting problems. So this is the resin tray. This is a top-down image of the tray where you pour the resin. And so Ember is literally open in that you can pour whatever you want into the resin tray. We don't prevent you from using someone else's resin. You can put whatever you want in there. And that leads to a few problems, which is some of the third-party resins that work with our with our projector actually attack the resin tray. And so this resin tray cracked due to a component of one of the third-party resins. And not only do we encourage you to do this in our software, we have third-party resins built in for the default. So it's not like this is just hey, you can do this if you want. This is literally built directly into the software. You can use other people's resins. But that leads to problems like this. So we've got to change up the materials and make a new tool to make this thing. So you get some problems when you open your platform. So what we're doing here and officially on Monday is we're opening Ember's firmware and the electronics. So it's more fun. This is the electronics. So the electronics are a clone of a BeagleBone Black, and we've made a few improvements. There's a USB hub, there's additional memory, and there's a few power management. And we're releasing this under a Creative Commons license. This is a flowchart of the firmware. We're releasing the firmware too. The firmware runs both on the Satara, on the BeagleBone, but then also on a couple AVRs for the motor controllers. Now, the board itself, it's a 6-layer board, so you're probably not going to fab this thing yourself. It's a pretty complicated board, but again, this is a commitment to an open platform. It's a commitment that we're doing this differently. We want people to come in and look at what's going on. We want them to understand. We want effectively to make this whole 3D printing and additive manufacturing thing a lot better by thinking about it in an open way. If you really, really want the stuff before it goes live on the Ember site on Monday, here's a horrible URL that you can take a picture of to get it. But if you want to see it on Monday, it'll be at ember.autodesk.com. Now, doing open source in a billion-dollar publicly traded company has some interesting connotations. So this is a fun email that I received from our legal director, and we compromised on. So in this particular case, I told her that I would contact her before I quote open sourced anything further, and we agreed that I would advise all of you that Ember is a Class A device, meaning that it is meant only for businesses and not meant for residential, because we didn't put a big enough Faraday cage around the thing, so it spits out a bunch of EMI noise. That said, here we are. So when you open source stuff, you have to run it by legal. That's it. I hope you guys will all check it out. Thanks very much for your attention.